We're discussing further material on data types. Probably the most important data type in the language is int. So int gives us a basic way of manipulating integer data, and that data type includes variations on it, and they will be explained shortly. There is a short form, a long form, and an unsigned form. So let me give you my understanding of how to approach learning a difficult subject like programming. In programming, you have lots and lots of stuff. Much of it is obscure. But if you concentrate on the things that are typical, and int is typical as a data type, then you can get 90% of the value of your study or your work by only looking at 10% of the entire language. So this is one of the places where the 90-10 rule shows up. Really make an effort to understand the data type int, and that will help you with all the other and more complicated data types, such as the floating types. On your typical modern machine, an int is stored in 32 bits. That's 32 zeros and ones. And it's even worthwhile, especially if you're going to go into computer science, to learn how to work in binary. That's the base 2, as opposed to how we're writing most things, which are base 10. It's also worthwhile to learn how to write an octal, which is base 8, and hexadecimal, which is base 16. And we may show some of this later on. Now, when you're working with an int stored in 32 bits, then what you can represent is limited, and it's limited to plus or minus 2 billion, and I've written it out here explicitly. You can go positively up to 2,147,436,647, and your smallest number, your largest negative number, another way to put it, is 2,147,483,648. It's not symmetric because of the fancy way people represent integers on the machine. It's called a 2's complement representation. Typically, the first bit is in fact the bit that affects how you interpret the sign. So you also have these other forms of ints: short, long, and unsigned. Short, it means use less data. Long means use more, a bigger range. So short can mean a smaller range. Typically, you're using fewer bytes. You'll see in a second when I write an example that for my machine, short is 2 bytes, ordinary int is 4 bytes, as we've already said, and then long will be 8 bytes. And then there's a further type, which is called unsigned. And in unsigned, you want the data to only be interpreted as positive. So in effect, if you have 4 bytes and you only interpret it as positive, you now have a range from 0 to a little more than 4 billion. So again, this can be very helpful, and it also can mean in a domain where you don't need negative integers, you have an ability to use the machine to work only with that type. Now, for each of these types, there's a way to present a constant. And I'm just showing you here, here's 35, that's an ordinary int. Here's 35 long, and it also can be a lowercase l. This is 35 unsigned, which can also be a lowercase u or an uppercase u, and this is 35 unsigned long. So you should have all of these available on your machine. This is quite important to know which type you're using, both for input and output, because in input and output, the different types take different formats. And you may find yourself mixing the types, and if you mix the types, you have to know what domain you're in, and you have to know how the operations affect values taken from that domain. So a classic problem in programming with a language like C is the fact that the operator divide can be either an integer operator or a floating point operator. And if you have two integers, it's 2 divided by 3, which is 0. There's no remainder. If it was 2.0 divided by 3, or 2.0 divided by 3.0, or 2 divided by 3.0, where one of the arguments or both the arguments are double, then indeed you would be in the floating point type. You would have a type of float or double, and your result would be 0.666. So this mistake gets made often when you are thinking you want to do something like average over some integer data, and you forget that dividing can be either an integer operation or a floating point operation. You can get a mistake. Okay, let's look at some code. So here's some code that I wrote to illustrate some of these ideas. And you can play with code like this. You should play with code like this if these ideas are novel to you. And you should extend it. And you can see in this code, I have a short. Short's a keyword. It really means short int. I could say short int, by just saying short. I'm typing less. So here's my variable name, and I assign it a 5. Here's a normal integer, int normal a, and I've assigned it 67. Here's an unsigned integer, and I use in that literal 67 to have a u. This is a long, and again, in order to make sure that the literal is in the right domain, I say 67L. And then here I'm doing some things to show you what the effects of using that. So here's that divide by 2 problem, where at first I divide by integer 2, and then I'll divide by floating point 2, and you'll see a difference show up. You'll also see that here, for short, I use the format HD, whereas normally I could have just used D. And here's another weird place where you'll see that the use of the format type will affect how something is represented. So 67, which is the value of normal A, when presented with the format type C, should show up as some kind of character. We'll see it in the ASCII table. And here is where we can print on my machine, because this is a dynamic operation where size of looks up the type and says a short A, which is type short, what size is being stored in on this machine under this system. And we'll see those values as well. Let me run that. And there we are. Short A was 5, divide by integer 2, and we get not 2.5, but 2. But short A divided by the float 2, that should be 2.0, will be 2.5. 67 as interpreted as a character from the ASCII table would be a capital C. And then sizes in the bytes on my machines are 2, 4, 4. The second 4 is for unsigned, and then the biggest is long, which all makes sense.